Scare us. But what do you see there and there? The same base. Who's in charge of this question? Are you crying little babies that hide from numbers?
Yes.
What are they going to do? Beat you up? I know 7, 8, 9, but other than that, are any of them really scary? Of course not. When you see two things that are the same, you're the boss of that question. Are you allowed to rewrite it thusly?
No.
X to the negative 4 to the 2 and x squared to the 3? Are you allowed to do that? Of course you are, because you're in charge. Those are the same. Are x and x the same? So can I do this math? Sure I can. What's this? He waited patiently. X to the negative 8. What's this? X to the 6th. What do you do with those exponents? You add them to get x to the negative 2. But in the original question, there is no x. What is it really? Negative 3 halves to the negative 2. What does a negative exponent do to its base? Starts with an R, ends with an E, has reciprocate in the middle of it. Reciprocate. Negative 2/3 squared. Negative squared is what? Positive 4/9. Scary? Here, scary. Here, what you've been doing since the first day. So what's this really? What you've been doing since the first day, isn't it? Right? Right. Now I'll wait a moment for that to sink in. Because for some reason, this move right here, everything highlighted in green, for some strange reason, makes all of you melt your brain a tiny bit. Even though this is one of the most powerful things you can do in math, and I'm going to use this example hundreds of times, every time you see it, you're still going to be like, what? So everybody take a moment to absorb that. You can change how questions look because you are the mathematician. The math is not doing you. You are doing the math. And you can even use the slang word there because that's what's happening. Okay? Okay. I'm going to have a sip of my coffee to make sure you have a slight extra moment to have that soak in. Oh no, I forgot to breathe in. What do I do with number 3? Does it look scary? Of course it looks scary. Why? Because there's decimals. But are all those decimals the same, Derek? They are. So what am I allowed to do to make it appear easier to me? Change it to what, Maddie? I could make it an X, but let's say I'm sick and tired of X's. I'm going to make Y. Right? That's the trouble with algebra. He's always asking about his X. I don't know why. X cubed times x to the 4th over x to the negative 2 is what? X to the 9th. But there's no x there.
It's 1.4.
It's 1.4 to the ninth. Now, if I was a real tool, I would make you actually give me that number without a calculator. But I'm only a fake tool, so I'm not going to make you do that. I'm happy if you get to there. But if you did have to do it, I would go 14 over 10, 14 to the ninth, and 10 to the ninth. That's what I'd do. Yeah? Yeah. What makes 7? What makes 4 frightening? Fractions. But if it was all just regular exponents, what would you do? You'd add the bottom ones, and what would you do then? Subtract. So that's all we're going to do now. 7 to the 2/3 over, what's 1/3 plus 5/3? 6/3, which is what? 2. 7 squared. Because the squared is 1/3 plus 5/3 to get 6/3. Now, what will we do with 2/3 and 2? Subtract. Just like Mrs. Bag Crumble taught us in grade 4. 2/3 minus 2. Can I do that? Yeah. Not like that. I got to do 2/3 minus 6/3, which would be what? Negative 4/3. So my final answer is 7 to the negative 4/3. Can I leave it like that? If I didn't want full marks, I could leave it like that, because something there is not allowed. Negative exponents. So this should really be 1 over 7 to the 4/3. If Mr. Myers said simplify, could you leave it like that? Yes. If Mr. Myers said simplify in exponential form, could you leave it like that? In exponential form. Yes. If Mr. Myers said simplify this in radical form, could you leave it like that? No. What would you have to make it? 1 over what? Cube root of 7 to the power of 4. And you could even simplify that once more, which I am never going to make you do, but I do want you to see it. Okay? What I'm about to write, you just have to look at. This is technically 1 over the cube root of 7 to the 4th power, yes? Right? So how many 7s are under there? 4. How many 7s do I need? 3. So this is really 1 over 7 cube root 7. Everybody understand? This is where you'll be going. But I'm happy if you get to here. Okay? Okay. What'd I just say? Okay. What'd I say last week about you guys chitter-chatting when I'm showing you stuff? Not to do it. Or what? Yeah. Oh, were you? Okay. What about it? She didn't understand this part? That's okay. You don't need to. I just wanted you to see it. What about 5? Is 5 weird? Of course not, because you apply your previous knowledge. If there were no y's, would you know what to do? Yep. If there were no x's, would you know what to do? So just do it. X to the 5, y to the what? -2. A great many of you on your test are going to leave that answer. Yeah, you are. A bunch of you are. What's the real answer? X to the 5th over y squared. Number 6. If there were no letters, what would the answer be? 2. If there were no 10 and 5 and no B's, what would it be? A squared. If there was no 10 and 5 and no A's, what would it be? B to the 5th. So if you know how to do each single one, do you know how to do the whole thing? Of course you do. Until test time.
There's no A on that.
Anything weird about 7? But it's easy to fix, isn't it? What would you do to make 7 prettier? What's -5 times -3? Positive 15. What do you do then? 15 minus 5, which is what? 1.5 to the 10th. Am I happy if you leave it that way? Yes. What else could you do? 15 over 10, both to the 10th. Nice. 8 now puts every single thing from the entire unit together. Everything. I could make number 8 the only question on your test. Because it has... Oh, I lied. It doesn't have any negative exponents. I would have to have a second question if I made 8 your test. So what would you do? What would you do, Jacob? You'd change all of it into cube root. You would say the cube root of 8, a cubed, b to the 6th. Yes? That's bodaciously awesome. Everybody should be able to do that, yeah? If there was no letters, what would the cube root of 8 be? 2. If there was no 8 and no b, what's the cube root of a cubed? A. What's the cube root of b to the 6th? B squared. Done. That's doing it that way. Is there another way you could have done it using your exponent laws? If this was not a fraction, you would just bring it in, wouldn't you? So that's what we'd do. We'd have 8 to the 1/3. A, 3 times 1/3 is 1. 6 times 1/3 is 2. 8 to the 1/3 is 2. A to the 1 is A. B squared is B squared. And you have the same number. Everybody good? All right. Prove it. You do 9 and 10. some of you are able to work number 9 as it's written. But some of you, I would like to offer you this strategy. If this seems too busy to you, break it up. You have 4 over 2. You have a to the negative 2 over a squared. And you have b to the 2/3 over b to the 1/3. Right? What's 4 divided by 2? 2. What do I do? Are these the same base? So what do I do with the exponents? Subtract them. What's negative 2 minus 2? What do you do with these? You subtract them. 2/3 take away 1/3. 1/3. Now you just put it all together. 2a to the negative 4b to the 1/3. Is that okay? It's okay if you want 3 out of 4. What do I need to do? Get rid of the negative. 2b to the 1/3 over a to the 4th. Can you leave it like that if I say I want it in radical form? No. Can you leave it like that if I say I want it in exponential form? Yes. If I want it in radical form, what's the only thing that changes? The b would become what? 2 cube root b over a to the 4th. And the only thing that would make you make that change is if I asked for it. Because I'm betting most of you would rather just do your exponent laws. Yeah? All right. Now, number 10 truly has every single thing you've learned in this whole unit in it in one question, gag, and go. Why did the 2 go out here? Because there was a 2 here. It's a coefficient. So it has to stay there. Because it's not getting any exponents, not being rooted, it's just itself. Jacob.
So when I didn't finish, but when I started by like cube rooting both numbers. Like, why never mind, that wouldn't work. Nah, okay, I thought there's not a graph here. I don't know what.
Good man. All right. Number 10. I doubt people are finished number 10 when I started going over 9. So finish up number 10 now. Remember, there's more than one way to do it. So I'm going to be asking numerous people to volunteer their method. And then what do you have to do? If you didn't have what they have, you have to choose a method that works for you. Who makes that choice? You make that choice.
Oh, is that supposed to be an A beside 25?
No, it's supposed to be. Do you guys not have the A?
No.
Oh, there's supposed to be an A by 25. That's weird. I have the A by 25. That would have made this crazy difficult.
Yeah.
Excuse me. You're not bad. Oh, don't be soft. Don't be soft. Calculators have made you guys soft.
That was like super easy once I actually thought about it.
Who's feeling confident? Maddie's feeling confident? Sounds good to me. No, Maddie, I only want to know the first thing you did. That's it. I know you've done something with this question. Of course. That is perfectly acceptable. Maddie noticed that inside the brackets here looks a lot like that question, doesn't it? And Maddie said, if it works once in math, it always works in math. So Maddie went 100 divided by 25, and then she probably went a divided by a to the fifth, and then she said, wait a minute, there's no other b's there, so I got to write a 1 over b to the negative 1/2. What was 120 or 100 divided by 25? 4. What is a divided by a to the fifth? A to the negative 4, right? That should have been green. And negative 1/2 down here, where should it have gone? It's already on the bottom. So where should it have gone? To the top, b to the positive 1/2. Then she said to herself, all of that is to the 1/2. Right, Maddie? Right. And then she had a choice. She could have distributed this 1/2 to everything, yes? Just like we did on number 8. Or she could have done what Jacob did on number 8 and recognized this is all square rooted. Right? I don't care which one you do. Some of you will want to do this. 4 to the 1/2, a to the negative 2, and b to the 1/4. Because you multiplied it in, right? What's the square root of 4? 2. A to the negative 2, is that allowed? That would go down here. And b to the 1/4. Is that okay if I said exponential form? Yes. If I said radical form, would that be okay? No, it would become 2/4 root b over a squared. That's if you did this way. Do you have to do it this way? No. Observe. Could I have taken the square root of this whole thing? Because that's square root, right? Could I have done this? Is that okay? But then it gets a little hairy, doesn't it? Because what's the square root of 1/2? Right? It's kind of yucky. Yo.
Is it okay to solve the inside first?
That's the next thing I was going to say. Do you have to deal with everything ever? What we did really was, the first thing we did was solve the inside first, right? That's what Maddie started doing. And it worked fine. Everybody good? All right. Now, 99% of you, when you are faced with a question like this one, like 11 and 12, almost every single one of you, and I mean this because I have taught groups of 30 of you 3 times a year for 20 years. When you are faced with this, the first thing you do is start substituting right away. And you all, again, not all, 99% of you will write, okay, negative 2 to the 3/2, y 3 squared times negative 2 to the 1/2, and then 3 to the negative 1. And then you'll try and work that out. 99% of you would do that. I, of course, would argue that wouldn't it be easier to have less x's and y's? So shouldn't we simplify first? What do I do with 2 x's and their exponents? Add them. What's 3 halves plus 1 more half? 4 halves, which is what? X squared. What should I do with y and y that share? I should add them. What's 2 plus negative 1? Y to the 1. X squared y. Now, how easy is it to sub these in? What's x? Negative 2 squared. What's y? 3. What's negative 2 squared? 4 times 3? 12. Easy peasy lemon squeezy. Simplify first. So what are you going to do here? Simplify first, right? Are you allowed to bring this 3 all the way through? Are you allowed? Yeah. Would it be a good idea? Why not? Because there's a bunch of crap inside, right? What did we decide on this very last question was easier? Dealing with everything all at once or solving the inside first? So what are we going to do here? Are we going to deal with this 3 on the outside, or are we going to deal with all this in the middle? We're going to deal with the middle? Sounds good. What should I do in the middle here? Can I do anything to this x to the 4 right now? There's nothing happening to it in the middle, is there? It's just x to the 4th. This is where it gets crazy. What is happening here? Because this is about the hardest thing you can do with exponent laws, because it's confusing. Is there any negative exponents in that blue box? No, so there's no reciprocating, is there? There's a negative base, though, yeah? So what is the base in that blue box? It's negative x to what power? 3. How many of them are there? 4. So this blue box gives me negative x cubed how many times? 4 times. Oops. Negative x cubed. Does everyone agree? Okay. What does this really mean? Look closely. It's very tricky. I give you a hint. Is that the same as that? Are they the same? What's this really? Negative x times x. What's this really? Negative x times negative x, yes? Which of those two do I have here? Top one or the bottom one? Look closer. I have the top one, don't I? So what is this really? X times x times x, yes? And all of that is what? Negative. What's this really? Same thing, yeah? Negative xxx, right? What's the next one, really? Negative xxx. And the last one, negative xxx, correct? How many x's do you see? X to the what? 12. What's negative times a negative? Times a negative? Times a negative? So this blue box is really x to the 12th, isn't it? And then what did we have at the very beginning? What's outside of the blue box but still in the brackets? x to the fourth. So what happens when I then bring x to the fourth back to the party? What do I get? X to the 16th. But that's not the answer, is it? Because what's living out here? So that's cubed. So that's really x to the what? 16 times 3. What's 10 times 3? 30. What's 6 times 3? What's 30 plus 18? 48. Now, what's x? Negative 2 to the 48th. Can you evaluate that in your head? No, of course not. I would never make you. But I would ask you this in your head. Is that answer going to be positive or negative? Positive, because that x is going to repeat an even number of times. Everybody cool? This is my biggest concern. Right? Because this is scary. But if you write it out, is it scary? You can quite plainly see how it worked, yes? All right, listen up. Your homework, in case you were unaware of there being work to do after a lesson, is page 110, 2 questions, and then how much of 111 and 112 do you need to do? As much as you need to feel confident. If you do not do any of that and do poorly on your test, whose problem is it? Yours. Is there any question on page 111 or 112 that I have not shown you how to do? No.